Hello guys, welcome back. And today we're gonna see how a GFCI receptacle works. This is an old one, so we're gonna dissect it and see how it works on the inside. A lot of people ask me how things work, so this one is all brittle and falling apart, so we're gonna take it apart and then just throw it to the trash. So, drink. So here it is, first look, at least in the back of the inside of a GFCI receptacle. By the way, since we're here, this golden colored screw terminals are hacked, and the silver color screws are always neutral. Also, if you look at it from the front, the long tab or slot is gonna be neutral, and the tiny slot is gonna be hot. And as always, round. Not much to see in front, just the terminal, and in the back, with that, see if we can take this apart. So there it is. What we got here is a sensing device. It basically, this current transformer right here compares the current passing through the device, and this is the ground fault controller. It's sort of a comparator in GFCI interrupter. That's basically the brain of the device. This guy compares the current going in and the current going out through the receptacles that are basically on this side. And when things don't work as intended, which is basically, it basically compares if there is a leak of some sort. We call it ground fault, because current is supposed to go in. Current is supposed to go in, and current is supposed to go out through the neutral. So it's basically supposed to come in through the hot and back to the source through the neutral. So if that doesn't happen as intended, this little guy right here shuts off the power to this guy. This guy right here, which is basically the relay that goes when there is a fault condition. When you hear that, when something happens and you hear that little click, that, which actually in your GFI you're gonna have a little test and reset button. If you press those, you can actually hear the relay working, which is that. At the end of the video, I'm going to put the schematics and specs for the control chip, the GFCI control chip. This particular model of GFCI receptacle, for those interested in the specs, then hello guys, welcome back. I just wanted to introduce you guys a brief history about the GFCI. It was created by Mr. Charles Dalziel, a professor of electrical engineering at the University of California. He invented the ground fault circuit interrupter, better known as the GFCI, in 1961. The theory behind it is that the GFCI operates by measuring the current balance between two conductors using a differential current transformer, which is the one I showed you in the little GFCI that I took apart. The device will open its contacts when it detects a difference in current between the live conductor and the neutral conductor. The supply and return currents must sum to zero, otherwise there is a leakage of current to somewhere else, such as earth or ground. This process is better known as a residual current detection. And the reason it talks about the imbalance between neutral and the live wire, which is the hot, is because even though we use the ground conductor as a safety, it's basically, the ground conductor is all about safety, is nothing but a safety measure designed to dissipate lightning and ground faults. But ironically, in this case, this device, the GFCI we're talking about, is designed to detect any possible leakage to ground. Basically, anything other than the current flowing through the hot to the return path, which is the neutral, is assumed to be a ground fault, therefore shutting the circuit off through the relay. So in this case, in the case of GFCIs, ground is not really necessary for operational purposes, but as far as safety goes, you must always have a ground conductor connected to it in case there is a short to ground. The residual current detection is complementary to overt current detection. Residual current detection does not provide protection for overload or short circuit currents. So that's it for today, guys. That's how GFCI receptacles work. As always, thank you for watching. Please like, share, and subscribe. See you in the next one.